So today I've got a nice CodeWars, which is around a rope burning puzzle. But before I get into that, I just wanted to, kind of point out the elephant in the room. I've been kind of away for a bit. I've been focusing a lot on trying to pay off the last of my mortgage. So I've been kind of hardcoring it with my IT software engineering consultancy that I run called 40 Tech. 40 Tech because my name is William 40, of course. And yeah, I just wanted to acknowledge that it's been a while and to just say that I'm intending to ramp things back up again. And I had the thought that perhaps people wanted to know a little bit about my background, what I generally work on a day-to-day basis. So I thought I'd give a 30-second summary of what I've been doing recently. So I live in the UK, I just outside of London. I work mainly for companies in London, particularly in the finance sector, and also in crypto-related things, and more recently in AI. So I've got a few companies here. So I started getting experience in finance in Nationwide Building Society, which is a UK-based bank, essentially. Moved on from there to a cloud-based company, so using lots of AWS-related services, and building a platform for collateral management in the finance space. It's a bit kind of dry finance-related stuff. Moved on to more crypto-based things. So Archax is a company that I worked for in the crypto space, where they have a assets and crypto trading platform, which is quite an interesting place to work. And recently I've been working for something, so I don't know if I can actually reveal the name of the company, but it's, again, in the cryptocurrency space. It is a tool for hedging risk based on Bitcoin difficulty. Kind of interesting. It's giving me the opportunity to get a lot closer to the actual blockchain technology itself. Did some really cool calculations recently around calculating the approximate hash rate for Bitcoin, which is actually quite an interesting calculation. And another really interesting project I've been working on has been essentially a chatbot, which utilizes a lot of ChatGPT related APIs, and it's like a workflow building engine that does all sorts of fun little things. So there you go, there's a little window into what I'm doing. And with that, on with the video. There is rope. It has a lot of branches. Choose a point on the rope and then ignite the rope. The rope will burn in 4 directions, up, down, left and right, burning 1 centimeter per second. Please calculate how long does it take to burn all the rope to ashes. So we have an example of the 2-dimensional array that we might get. R represents a piece of rope. And you can see that if you lit the rope here, it would take, given that it's 1 centimeter per unit, and 1 unit is a second, it would take 1, 2, 3, 4, 5 seconds to burn this entire rope, because all the paths, well, this is the longest path from top to bottom. So yeah, you could imagine that the rope might spiral all around. It could go all sorts of different directions, could go in a spiral or, any kind of intricate maze shape. So the algorithm we need to produce needs to find the longest path, I suppose, between the ignition point and the longest point, wherever that might be. So when I was thinking about this, it's not that difficult, really. You just have to propagate the fire in all directions, and count the number of propagations that it takes in order to convert the entire rope into fire or ash. And it got me thinking about other things that I've done and where I've utilized a regex. So I thought it might be fun to implement the burning aspect as a regex, which I have done. And I'll just quickly talk through the solution. It's probably wildly inefficient, but I had fun doing it. So there we go. I'm going to share it with you. So we get the start and end point as coordinates. And of course, we have to actually ignite rope to begin with. And if we don't land on the rope with the ignition point, then we have to return -1. Otherwise, we set the rope on fire. And I'm doing that by setting the character to a hash symbol. Now, because we're using Node.js version 8, you don't have things like flat, nice little array method that I like to use. So I'm kind of having to flatten the array kind of manually and join it together into a string in a bit of a clunky way, but it works. So I'm joining all of the characters together for each row, just concatenating them with no delimiter. And then for the rows themselves, I'm joining them together just using a pipe character, just so that there's a separator between each row. And I can therefore ensure that some of my regex matching doesn't span multiple rows. So I end up with a rope string at the end of it. I set a burns variable to 0, and then I've just got this loop here that checks if there's any rope left. So if the index of r is not equal to -1, so it finds r, then there is more rope to be burnt. In that case, we increment the burn variable by 1 and execute a regular expression which burns the rope. So the regex itself can be broken down into 4 parts for up, down, left and right. So this part is burning in the left direction. So it's saying if we have some rope followed by a character of the string which represents rope that is on fire, then we are going to match that and replace it with a hash to signify that this piece of rope is now on fire. Conversely, if we had a piece of rope that was on fire followed by a piece of rope, then that would be burning in the right direction. Similarly, that will replace that character with a hash to signify that it's on fire. And then we've got something here for handling up and down. So again, we've got a rope, piece of rope, and a look ahead, which is looking for the exact number of characters to wrap until the next line, and then followed by a hash. So this comes from here, and you'll see that I'm inserting this RL variable. RL is equal to the first row length. So you can see that that will just match the number of characters for the entire row, which wraps it around to the exact position on the next row, and then attempts to match the hash. So that means you've got a piece of rope and then a piece of rope that's on fire on the next row immediately below it. And then we've got basically the exact same concept, but just going in the opposite direction. So doing a look behind rather than a look ahead to match the characters in the reverse order. Executing that regular expression, it will effectively do a find replace on the up, down, left and right characters. And if they are ropes, it will convert the ropes to hashes. So then repeating that in a tight loop over and over again will eventually just propagate the hashes in all directions, following any paths that it's able to find. And ultimately, once this condition of not being able to find the R character, once that returns true, the whole rope is burnt, and this burns variable has been incremented to the correct value. So giving it a test, you will see that it passes. it's quite a fun little solution to this rope burning problem. So I hope you enjoyed that quick one today, and I will see you hopefully on the next video.